Welcome to my video tutorials. Current tutorial is dedicated to oscillatory circuit resonance. Part 1. In this example, we will talk about resonance when two reactive elements, inductor and capacitor, are connected in serial mode. To be closer to real circuits, we need to add one more element, active resistance, to prevent any short circuit. In such circuit is possible the resonance of voltages. Let me show this on the following vector diagram. Resonance tells us that voltage of capacitor and voltage of inductor have the same value. Means reactive voltages are equal to each other. It is possible at exact frequency when voltage of inductor is equal to voltage of capacitor. And this frequency is called resonant frequency. Resonant frequency can be defined by the following equation. As a result, we will have two different cases, when frequency less than resonant frequency and when frequency is higher than resonant frequency. From our previous tutorials, you already know basic equations which describe any RLC circuit. Current in this circuit, respective voltages. Current and voltages can be shown on the following vector diagram. And as you can see, two reactive elements, capacitor and inductor, depend on frequency. Respectively, these two elements lead to resonance. And in first case, when we have resonant frequency, the inductive reactance is equal to capacitive reactance. Respectively, voltage on capacitor and voltage on inductor have the same value. Then we have situation when frequency less than resonant frequency. Taking into account the equations which describe respective reactances, we will have that value of inductor reactance less than value of capacitor reactance. So in the last case, when frequency of input signal generator has the higher value than resonant frequency, we will have reverse situation, means inductive reactance has the higher value than capacitor reactance. Now let's analyze all these due to vector diagrams. It helps us to understand everything clear. In first case, in case of resonance, when frequency of the input signal generator has the same value as resonant frequency, we will have the following situation. Voltage of resistor and current in the circuit will be on the same axis because resistor is active load. Then reactive voltages, which have phase shift of plus 90 degrees and minus 90 degrees respectively, will have the same value. Respectively, total reactive voltage is 0. Then, in case when frequency of input signal generator has a lower value than resonant frequency, we will have higher value of capacitor voltage than value of inductor voltage, which tells us about capacitive character of the circuit. And the last case, when frequency of input signal generator has the higher value than resonant frequency, we will have higher value of inductor voltage than the value of capacitor voltage. It tells us about inductive character of the circuit. The same we can see on impedance triangles. In the first case, we will have that reactive resistance, or total reactance, is equal to 0. Means active resistance is equal to circuit impedance. And in other two cases, we will have the following impedance triangles. If we look on the basic equations, we remind ourselves about Ohm's law. When resistance is increased, the voltage is increased too. And when we're talking about reactive resistances or reactances, these reactances depend on frequency. To help you understand everything clear, I'm giving you the following table, which describes how reactor resistance or reactance depends on frequency. Thus we have, when frequency is increased, the circular frequency is increased too. And inductive reactance is increased, but capacitor reactance is decreased. And if we build two graphics of two reactive resistances, means two reactances, on one plot from 0 to infinity value of frequency f, we will have the following situation. When cross-section of these two graphics gives us the resonant frequency. And yes, in this point, capacitor reactance is equal to inductor reactance. The same we saw on vector diagram and impedance triangle. As you see in the serial RLC circuit, we obtain the resonance of voltages. Hope you understood everything clear. Thank you for watching.